On our previous video, we learned that ln of x near x equal to 1 is approximately equal to x minus 1 minus x minus 1 squared over 2 plus x minus 1 cubed over 3 subtract x minus 1 to 4 over 4. This is the fourth degree Taylor approximation to ln of x at x equal to 1. This means in an interval containing x equal to 1, ln of x equals, on the nose, the infinite sum above. And so we start with k equal to 1 and we go to positive infinity. We have these x minus 1s. Notice they're raised to the kth power. And notice in the partial series above, the denominator is just k. Also notice that the signs alternate. Once we start with a positive and k equals to 1, we need to raise negative 1 to the k minus 1. So when we plug in 1, negative 1 gets raised to the 0 power. This is the full Taylor series of ln of x at x equal to 1. The question is, what is this interval? To answer that question, we use the ratio test. This interval is called the interval of convergence. To find the interval of convergence, we use the ratio test. So we increment k and take the absolute value. So since we're taking the absolute value, we can not write the negative 1 to the k. So we are simply going to take the non-alternating part of the series and increment k, x minus 1 to the k plus 1, divided by k plus 1, and we need to essentially multiply by the reciprocal. That's because we're applying the ratio test, which is dividing by the kth term, and take the absolute value. This is the absolute value of a sub k plus 1 over a sub k, where a sub k is the kth term of the series in question. Shaking out the algebra leaves an x minus 1 up top, because the x minus 1 to the k below cancels with all but one of the x minus 1's upstairs, absolute value, and we're multiplying that by k over k plus 1. And we're taking the limit as k goes to infinity. By L'Hopital's rule, this k over k plus 1 will approach 1, and therefore the ratios of the terms approach x minus 1, absolute value, as k goes to infinity. So by the ratio test, if the absolute value of my ratio is less than 1, then you will converge. So we can guarantee from the ratio test that if this, then converge. So therefore, solving that looks like this. Negative 1 has to be less than x minus 1, which is less than 1. Adding 1 to both sides, you see that x has to be between 0 and 2. And so x is in the interval 0 to 2. A sufficient condition for the series to converge. Now the question you should ask yourself is, what about the endpoints? Each of those must be tested individually. Into our series, then our series becomes the sum from k equals to 1 to infinity. We had our negative 1 to the k plus 1. And instead of having x minus 1, we will have 0 minus 1 to the k. And that is divided by k. But because the negative 1 to the k plus 1 is really just negative 1 to the k times negative 1, and the second piece is also equal to negative 1 to k as well, then you've got really two negative 1k's up top. And they combine to give you a negative 1 to the 2k, which of course is just positive 1, because if you make negative 1 to some even power, well, you're going to get a positive 1. So really this is the sum from k equals to 1 to infinity of negative 1 over k, which of course is equal to negative of 1 over k added up from 1 to infinity, and this is the harmonic series, and this diverges. So what we see is that x equals to 0 doesn't work. So we are not going to include x equal to 0 in our interval of convergence. Now we just look at the other endpoint, x equal to 2. So here we substitute into our series. This time the opposite sign pops out of the upstairs. We still have our negative 1 to the k plus 1, except instead of putting a 0 here, we put a 2, which gives us a positive 1 to the k, which is just 1, and therefore this equals the alternating series, negative 1 to the k plus 1 of 1 over k. So by the alternating series test, since the limit of the 1 over k's goes to 0 as k goes to infinity, the alternating series test says that this series converges. And since this series converges, x equal to 2 works. And so we move back up to our interval of convergence and we add x equal to 2 to this. And so your interval of convergence is open interval 0 to 2, include 2. That's it.